This is Hallicrafters Rehabs. Welcome back. So we finally got my dad out of his things out of the cottage. This week has been very busy, and in among the dumpster full of trash that we emptied out of the basement area, there were bank records, bank statements with canceled checks in an envelope from the bank that was a 3-cent embossed stamp on the envelope. In other words, postage was 3 cents. So you can figure out how long ago that was by looking at any stamp list. Anyway, all that got thrown out, but in amongst that was in the mud, almost, or somewhat. A World War I German helmet. And my grandfather's tin hat from World War I. So we're going to see if we can restore this a little bit. First, we have to get rid of the rat or mice or whatever that could have been in there, and so we're going to let that soak for a little while in some bleach, and that will be the first step. And so that we can safely handle this, and so I've got a mop bucket here. I could fill that up to the top. I think I'll do that. And we'll just let that soak for a little bit, and then we'll apply some of our radio restoration chemicals. Probably acetic acid I might want to try first as a de-rusting agent. I do have plenty of evaporust. Maybe I'll use that, but I'm going to go first and fill that up to the top so that it's fully covered, and then we'll come back. Okay, well, this has only been soaking a few minutes, and look how bright this camouflage is coming out. That's kind of amazing, really. A little bit of de-rusting and that'll be really bright. So I'm going to go rinse this off because it's got chlorine bleach in it. And we'll come back. Now we'll see if we can fit the German helmet in there. I'm not sure it will go so well. Well, I'm going to have to turn it over. Well, we're really just decontaminating the rat part with bleach. Oh boy, it's got color on it too. I'll let that soak for a little bit. I'm just going to turn it around. There's not enough space in here for everything. These things were colorful. Okay. Yeah. All right. So we'll let that go for a little while. Then we're going to come back and put something else on it. Okay, this is what the German helmet looks like after its baptism, initial baptism in bleach water. And it's got some color too. I'm going to go rinse that off and put it in the sun, such as there is for sun. Okay, so I put the World War I tin hat, American tin hat, actually they're made in France at the time, in some acetic acid, and it includes a degreaser, which I'm not too happy with, but it was cheaper than regular acetic acid. And it's diluted with some water too, and it foamed up. I didn't like that either, but anyway, we're going to let that sit for a while because it's cold water and it's cold out here, and it's going to be pretty slow acting no matter what. So we're going to let that soak, and then we'll do the other one. Just to assure you, this is still a radio restoration channel. This was actually my mother's AM FM radio that she had in her art studio 35 years ago. Keep her company when she's out painting out in the studio. And this was a 15-minute restore. Basically,
on the new K-Love app,
I spray with the Super HFE and
butter coat,
and
finally,
some deoxit down here in this AM FM switch. Very sensitive. 15-minute restoration. Nothing more. It's all solid state. Nothing more need to be done to it. There are some electrolytics in it, but they're not highly stressed because they're low power electrolytics, and there's no hum in this thing. So done in no time. And a new addition to the shop. Okay, so I've it's been over a week since I started this video with the 15-minute restoration of the AM and FM radio and our World War I helmets. I'm not sure I'm going to be able to do much with the U.S. helmet of my grandfather's. It was really badly rusted, so maybe I can do something in the summertime when it's warmer, but it'll need something to stabilize the rust. And then and I have someone looking at the German helmet. So the real point of this video is I'm back with the original, my third SX-99 restoration. And I don't just put these on a shelf, I use them, and it's part of the burn-in process. This one seemed like it was kind of dull, not very sensitive, so I started fooling around with it a while back and looking at it with the spectrum analyzer, and it seemed like, well, it turns out that it was aligned to 455, but the crystal itself, right here, is moved up to 457. So they need to kind of be together, and they weren't. And I'm wondering if I inadvertently switched this one out with a spare that I had. I don't know. I've got another one, and we're going to pull this one out, and we're going to test them both, and we're going to see which ones is the lowest frequency. You can shave crystals, so to speak. Yeah, I mean, there's stuff out there about that, but I don't want to get into that. I'm not sure how successful that's going to be. If I can get it down close to 455, it's supposed to be, I had it up there, yeah, 454.2, so I don't know. Anyway, it measured out at 457 installed in circuit. Now, there's also a trimmer. Trimmer only comes into play in the sharp position. And I'm not too sure about it either. So I'm going to pull that out and run some experiments with that. Another problem with this radio was this 15 megohm resistor. And it's, June's on the phone. She doesn't know that. Anyway, this 15 megohm resistor, there was a hum after all this work on these radios, and it was intermittent, and sometimes it'd be there and sometimes it wouldn't. So I did my dentist thing, start going around with a plastic tool, and when I got to this grid on the AF amplifier, it went away, which tells me either I got a cold solder joint here, or there may be even a bad or intermittent contact with the tube. So we'll address that too while it's all open like this. So first we're going to remove the crystal, take a look at that, then we're going to do some experimenting with the this trimmer capacitor, which I'm not all too enthralled with. We'll get on with that. I'm not going to do all this desoldering here on in the video. You've seen plenty of that. Another thing I wanted to do was, this is the mica trimmer that came out of the circuit for the crystal, and one thing I noticed is it was very touchy adjustment. It was really hard to find, really, the peak with this, and so I have other options to put in there, so I decided to do a comparison of the sensitivity or the difficulty or the how the capacitance changes with the turn of the screw for this type of mica capacitor compared to this silver mica, which has got a little bit more capacitance to it, but it just rotates to change as 360 degrees, actually 180 degrees, to change through the full range. This, you keep unscrewing, it may seem like that gives you more, but it doesn't, because it is non-linear. When you have it fully tightened in maximum capacitance, and just small changes is larger in the picofarads associated with it. So doing some approximate measurements, because I didn't get out of a 90-degree scale or anything like that to try to exactly determine what position these were in. I just simply recorded turning of this in the picofarads as a function of degrees from 0, and for both type capacitors. I hope this is sharp enough to see, but at least you can see the curvature. So this is just a typical mica wafer trimmer capacitor. I'm sorry, this one is, the gray one, is a typical mica wafer trimmer capacitor. And so when it's real tight from 0 to the first 45 degrees of turn, which is very small on that capacitor. A very small change is 45 degrees. Then you have a pretty large drop in capacitance, and then it continues down, and then it levels off. You get to a certain level, and no matter how far you unscrew it, that's it. Whereas the silver mica, which is blue, is fairly linear all the way across until you get towards the bottom. And furthermore, they're pretty easy to adjust. So I think I'm going to put in the silver mica capacitor just to see if that doesn't make it easier to find the peak in the narrow bandwidth setting of the SX-99. Okay, it's the next day actually, and I've been doing a lot of experimenting and research and all sorts of things on how you might be able to modify a crystal in the condition that it is in, the frequency of a crystal. And I threw terms like this yesterday around, like shaving the crystal. I didn't know what I was talking about, and we'll go into this in just a second. A crystal is simply a quartz rock, if you will, that's been cut to a certain size, and in reality, that size is a mass. That's what's critical. Obviously, it has to be able to oscillate inside a chamber, and the chamber is made up by this little box here, which is easily taken apart, and I'll demonstrate that in just a second. And the crystal that you're looking at, when I measured it yesterday, was 459.3 kilohertz. It's now resonating at 457.3 kilohertz. And how was that done? It wasn't done by shaving. If you shave off or rub off or remove any material from the crystal rock, you've actually made it smaller, which going back to our physics, a smaller mass has less momentum, less resistance. And what you have inside this box is you're energizing each side, and it's got two metal plates, which we'll see in a second. And between that plate, there is a voltage that is varying in AC voltage at RF frequencies. And the energy of that oscillation moves the crystal, and the weight, essentially the mass is a better term for it, physics, determines the frequency that it will oscillate back and forth. Because quartz is a crystal, it has a property of oscillation, but its weight and shape, to the extent that it is able to move back and forth. You don't want to have just a lump of rock. It works better, shaped and all that kind of stuff. The mass then determines what frequency it will resonate at. So I did some research, and if you have a crystal that's too low, which is almost never in this application of a crystal which is determining the IF frequency of a tube communications receiver. If it's too low, then you have to remove mass, and that's where the term shaving comes from, and I would probably try never to get into that. When you have crystals for RF transmitters, and this crystal determines what frequency you're transmitting on, yes, that you sometimes have it too low and you have to get it higher, or you sometimes have it too high and have to get it lower. Well, how do you get it lower? Well, you have to add mass. So the term is called pinning, and people have put graphite on these crystals. The recommended method was to use a Sharpie pen and paint a layer of Sharpie on the side to add weight to that crystal, and that probably works very well in the 40 meter, 20 meter, those kind of transmission crystals and things like that, where the frequencies are very high. But 455 kilohertz crystals used particularly in tube radios for referencing the oscillator is a pretty good size rock compared to those that might be in 20 meters or 40 meters or 2 meters or whatever, or in your watch. Actually thinking of what, like a clocks, I just got through servicing several pendulum clocks. And again, if it's going too fast, well, the easy way to handle a pendulum is to raise or lower the pendulum weight. But essentially, you're just using leverage instead of adding weight to the pendulum or taking it away. But it's the same principle. In a quartz crystal in a watch, again, it's resonating at a certain frequency. That frequency is precise, and it's determined by the weight of the crystal. And then the watch or the clock or the radio is energizing that quartz and taking the resulting resonation into its circuit to reference whatever you're doing, whether it's timekeeping or RF frequency. So to pin I did try pinning this crystal with a Sharpie, and I was able to move it from 459.3 down to 459, basically with 2 or 3 layers of Sharpie. Not good enough. So more brute force was needed, and I've settled on painting the crystal. And you have to let the paint dry. Okay, the paint's wet, it sticks to the plates and doesn't oscillate. So you have to be patient. Okay, patience, and let it dry. And if you make it too thick, there's not enough room in the chamber for the oscillation, and it won't oscillate. So I'm going to reposition the camera, and what we're going to do is the one that came out of the set is at 457. So we're going to paint that crystal. See, right now I'm at 457, so I've got 2 457, but I don't know that I have enough room in the chamber for more and more layers of paint. And I rather would go, maybe if I get this one down to 455, then I can come back to this other one and see if I can make it a true spare at 455. So we're going to go through taking this crystal apart and painting it. Okay, so I have here the crystal. I'll put the other one way out of the way. That was taken out of this SX-99 set. Now this is a worthwhile exercise. To go out and purchase, this is why I'm doing this, a replacement crystal, you're looking at $45, because people don't use crystals like this anymore. They use very low frequency crystals for whatever purpose, I don't know, but it's related to electronics, and more likely they're using them at higher frequencies. And most of the time they are part of they have the oscillator included, and so it's actually a crystal referenced oscillator, and which sort of takes the place of the oscillator in the SX-99, and you have one little package. It's about a 10% of this one, which goes nicely into a solid state uh, electronic device, oscillator included, and a whole lot of other things not needed. So that's the difference between solid state and tube radios. However, when this is working, it will work very well. All right, so these crystals used in the Hallicrafters in this generation are very easy to take apart. So, and I can remember cleaning one, and I thought, this is really grimy and dark and got all this stuff in it. And now I know what I'd done is remove the pinning that was put on that crystal by some ham way back when. I had no idea what I was doing. But we're now going to do what he did. And we're going to paint this crystal. And guess what? That's the old one. So now you know what's inside. I have to put this back together and get the right one. Very easy to confuse. Maybe I'll paint this one so I'll know which one's which. Well, after much experimentation and work and so forth, the better crystal I've gotten down to 456, which is good. And we know exactly what the frequency is. And it's 456.033 or 0.025, depending on which instrument you're looking at. The signal generator says 0.025. So it's got a layer, a delicate layer of paint, and then about 3 layers of Sharpie on top of on one side, and that's about as far as I dare. The reason for that is I tried doing it both sides, and it's kind of like playing red and black on a roulette table. They just sort of somehow cancel out each other and doesn't do the job. So cleaning that, you just clean it off with, mistakes you clean off with alcohol. And then you get back to so one side is completely clean, and the other side is got the layers of paint and Sharpie and so forth to lower the frequency. And there is another aspect, and that is the more you do this, the crystal actually response degrades as well. So if I kept on working this, let me just sweep it. Okay, you've got a pretty good response there. But if it were pure quartz, it would probably be a little higher than that on the spectrum analyzer in terms of response. So we're going to go that's about as low as we're going to go with this, and we'll see how that works. If it's still kind of dull, I may have to go back and try something, actually replace the crystal. But I would rather see if this can do the job, even though it's not 455. It's better than it was. and we'll see how it goes. So next thing is to put it back in and see how it works. Okay, the crystal is back in, the trimmer is back in. This has been worked a little bit with resoldering and cleaning of the pins with deoxit. And this is probably 4 solid hours later of work, not calendar time, but work, getting the alignment redone at 456. It's actually at 456.5 on sharp, and on the broad is 456. It's just within 150 hertz of that. So it's for all intents and purposes, it's aligned to the painted or pinned crystal. And the procedure is not what's in the book. When you have the advantage of a spectrum analyzer, that's one thing, but also it's just still, they don't tell you what position. I went back and forth in the instructions. They don't tell you where to set the crystal phasing, and that has a huge impact. What you would do is you would set the crystal phasing. If you don't have a spectrum analyzer, you set the crystal phasing to get the maximum signal at in the sharp position. And the best way to do this, whether you're using a spectrum analyzer or not, is to get it approximate with maximum signal on the IF cans, and then start with the first IF can. I think it's T1, whatever, and do a top and start with bottom and then top, and look at the S meter, or you can use a VTVM. Now, I should say my signal is being injected at the stator of the middle section of the main tuning capacitor, which I can't get to except from the bottom and where it joins up with the switch. And I'm sweeping from 450 to 470 kilohertz, and then the pickup is going through this rather large multiple capacitor spectrum analyzer protection circuit with just a few picofarads really, but it connected to the grid to the detector, or maybe it's a plate, but it's the lead coming off the, I think it's pin 5 of the 6H6. And it goes to the spectrum analyzer, or you can use a VTVM or whatever. But at any rate, you want to adjust the bottom and the top in sharp for maximum output, and you have the crystal phasing, if you have a spectrum analyzer, set to give you the sharpest peak. You don't want any shoulders if you can avoid it. Then you go to broad, and there should essentially be no change. In this case, it's less than a dB between sharp and broad. And you keep adjusting the top and the bottom of T1 until there's essentially no change in signal strength between sharp and broad. And that'll get you the maximum sensitivity. Then you progress to T2 and do the same thing. And then T3 and do the same thing. And then you go back to T1 and do the same thing until no matter which one you're working with, there is there'll be a slight shift in frequency when you go between sharp and broad, but there's essentially no difference in signal. Now watch this notch action. So here comes the notch up. It's in sharp right now. Well, it's in broad. All right, we'll look at it in broad. I think it's in broad. Yeah, okay. We'll watch it come up like that. There you go. Then you have an almost no, very broad. And then there's that notch again. Then in sharp, you have a more pronounced notch. See there? And that's the way it's supposed to perform. When you're really happy with it, and there's nothing more to do, then you turn it to normal. You turn it to normal. And I really like this kind of mica capacitor. Look at this, it's a little bit off because I've been adjusting the others. So you get to see now, as I turn this, got to use the metal side for this action here. Look at that. That's the way it's actually a substitute for a crystal. And so you want it, that one marker there. Now when I lift away, the capacitance changes this. So I'd adjust it so it's a little bit low. You don't get that kind of action with these other trimmer caps. And by the way, actually design flaw of my redesign here, there is a little bit of interaction between the crystal phasing. You wouldn't be able to hear it on the radio, but you can see it on the spectrum analyzer. This crystal phasing is actually affecting the normal, and that's simply because there's no shielded lead from the there's a little bit of interaction between the crystal being energized or whatever, even though it's not going through the crystal. There's some associated harmonics or something. I'm not sure how you would say it, but at any rate, there's a little bit of influence that the crystal has and the crystal phasing has on that, due to we're not shielding right up to every lead, and there's not inside a shield box or something like that. So, but it's not enough really to detect by listening to the radio. So I'm going to take these pictures and then we'll come back. Okay, so now you're looking at the completed work on the third SX-99 that I did. And a few things happened. First of all, the first cut of this video segment, I once again forgot to put the mic on, but anyway, it's now working, and it's working very well. However, that's not the whole story. I went through an RF alignment after the IF alignment, and once again put it into an antenna, still with outside the case, and it seemed dull. After all this, that was not the real root cause of what was going on the sensitivity of this thing. So I took a systematic approach. You know, where is the signal and where is it not getting in, or what's happening to it if it gets in? And so starting with the antenna, I just took inputs first, simple inputs, RF or even the outside antenna, and you put it up to directly to the grid of the 6SG7, the RF amplifier, and there's lots of signal there, but it's not getting from the antenna to that grid only on 2 bands, bands 3 and 4. What happened here? You know, after all that effort I did on this, what's going on? So, the best thing to do in this situation was to, let's see if I can do this. So, just doing first a signal here was basically not getting to this grid right here. So, is it the switch? Is it these contacts? What's going on? And where was the common mode failure that would cause both of the signal not to get through these coils, but did get through these 2 coils in bands 1 and 2. And what you see is there is a common ground here, and then there's just selection between this or this for this coil, or this or that for that coil. Tracing. And finally, I started, you know, I removed the leads to these coils. I checked for inductances, it's all there, resistance is there. Then it occurred to me, these switches are hard to read, but you do have to read them. Switch 1A, front, viewed from rear. Switch 1A, rear, viewed from front. Thinking. I had the leads reversed up here because of this. So basically, coming in, this was wired to this side and that was wired to that side. Quick resolution. And now the radio is quite sensitive. It's all working well. And what we were listening to, by the way, is some Chinese station. If you don't know where it is, it's probably from China in shortwave. Let me get that back on. The other thing I had to do was reprogram the frequency counter, because it's programmed to subtract 455 before, and now it's 456. So this radio is working quite well, and in comparison, here we have the Mark 1 SX-99, all doing a very good job. So it's back. This it's not finished yet. While doing a final RF alignment with the K-zone, because the case affects things a little bit. The slug came out of one of the RF coils, and so it's rolling around in the bottom of that, and I'll have to get in there and put that back in, but it doesn't affect the performance because the slug was all pretty much all the way out for the highest sensitivity on the RF and band 4, but that's also a danger because you can easily knock it out of the core. But at any rate, it's now working well. Extremely sensitive. There's another Chinese station. They get down here to Romania. Just tons of we'll go down to 60 meters here. Just the foghorn stations are really there. Here is CFRX. Oh, they've sort of faded out right now, but at any rate, it's all working good. And back together until I get around to putting that slug back in, which you can't have rattles when you carry around radios. So, all done with this one. This one has a punch list associated with it too. That'll be the next video. So this is Hallicrafters Rehabs, and thanks for watching. Thanks for your subscribers, and for the patience with things like helmets, which somebody's looking at the German helmet, but nobody's interested in the American. So maybe I could do something with it this summer.